question number 51. The transition metal having lowest oxidation state among the following is. We have different coordination compounds given here. First is K4 FeCN6. Let's find out the oxidation number of the transition element, that is iron. So let's assume its oxidation number is X. So it would be +4 for potassium, +1 into 4, plus X we are assuming for iron, and then Cn. Cn is in -1 oxidation number into 6, and the sum of oxidation number for the compound is 0. And now for the value of X, if you solve this, you will find out it is +2. Now after this, here is FeCO5. This is iron carbonyl, and in this case, in case of carbonyl, the oxidation number of this ligand CO is considered as 0. That's why if you consider the oxidation number of this iron is X, then definitely it would be 0. After that, we have the third compound, that is FeH2O6 Cl3. In this case, if its oxidation number is considered as X, so this X plus oxidation number of water 0, then -3 for chlorine, because oxidation number of chlorine is -1 and 3 atoms are here, that's why it's 0. So X is equals to +3. The last is the compound of cobalt, SO4. In this case, if you consider that oxidation number of cobalt is X, then the value of X would be calculated. Ammonia is present here as the ligand, oxidation number 0, plus Cl is here, -1. Sulfate ions are here, -2. So the value of X, if you find out by considering the sum 0, X would be +3. So you have the oxidation numbers of all these elements, and what you need to find out, the transition metal having lowest oxidation state among the following is. So in this case, the lowest oxidation number is there for iron in case of iron carbonyl. That's given in option 2, and that's why this is the correct answer. Now after this, question number 52. Question number 52. Standard reduction potential of 3 redox couple which are given here. Let me underline them. Respectively are, the values are given here, 3.0 volt plus 1.2 volt minus 0.78 volt. Now with the help of these values, we have to just choose the correct statement, and that will be your correct option also. Let's check the values given here. In the first case, the reduction potentials are given. That's why this case can be represented as this, and for this, the reduction potential which is given is -3 volt. Now after this, the second case, P is here, so reduction potential is plus 1.2 volt. Now after this, we have C. For this, the value is also given, that is equal to -0.78 volt. So you can easily analyze these electrodes along with their electrode potentials. Let's check the options given here. A plus is strongest oxidizing agent. If you look at A plus, it is getting changed into A, but is it the strongest oxidizing agent? It is not. If you look at its reduction potential, this is -3.0 volt. That's why it is not the correct statement. Then B can release hydrogen gas from dilute acid. If you look at B, its reduction potential is 1.2 volt. It means it is not able to release hydrogen gas from dilute acid. This is also wrong. Now, third statement, C cannot release hydrogen gas from dilute acid. If you look at the electrode potential of this C electrode, then you will identify that it is 0.78, -0.78. It is able to release hydrogen gas from dilute acid. It means this statement that states C cannot release hydrogen gas from dilute acid is also wrong. Further, if A and B are metals. It is assumed that these two are metals. These are used to form electrochemical cell. Then B acts as cathode. So definitely the electrode with more reduction potential value can act as cathode. And if you look at this, B has more reduction potential value. That is why we can definitely use it as the cathode. And this statement is the correct one. On this basis, the correct answer for this question is option 4. Now, let's take question number 53. If E0 value for the zinc electrode is plus 0.76 volt and the E0 value for the copper electrode is plus 0.34 volt, then E0 cell for the reaction. The reaction is given here, and in this reaction, zinc is getting oxidized while this copper is getting reduced. So in this case, you have to just find out the E0 cell value, that is equal to E0 cathode minus E0 anode. And at cathode we are taking copper because it is getting reduced. So its value is 0.34 volt. It's a positive value minus. What about zinc? The value becomes 0.76 volt. And then if you solve this, you will find out that this value is 1.10 volt. And if it is so, option 4 is the correct option, and that's why I'll choose it. After this, question number 54. In a compound, if oxidation number of elements A, B, C respectively are plus 3, plus 6 and minus 2, let me underline them. 3 elements are there and their respective oxidation numbers are also given. Then you have to find out the correct formula of that particular compound. So when you look at the given compounds, you will identify that the compound present in option 2 can follow this. Let's check how it is following. This is the compound. This is A2BCO4 whole thrice. In this case, the sum of the oxidation number of all the elements should be 0. So let's check, is it so or not? Plus 3 into 2 plus. For the B, this oxidation number is plus 6. Then here is C4. The oxidation number of C is also given, that is minus 2. And how many atoms of C are there? Into 4. And whole thrice is there. It should be 0. We have to just check. Let's check whether it is so or not. So it is plus 6 plus 18 minus 24. So if you find out the value, this is equal to 0. And if it is equal to 0, it means this is the correct formula. That's given here is the correct formula of the compound formed by these elements. So where this option is given, we have already chosen it. This is option 2. While if you look at the other options, it is not followed. That's why only option 2 is the correct one. Now after this, let's take next question. Question number 55. If the solubility of AgCl in water is 0.07175 milligram per liter at particular temperature, then its solubility product KSP will be. Atomic mass of Ag is given, that's 108 U. So here the most important thing that is given is the amount of this AgCl, but it is in mg per liter, that you should know. And you just have to find out the KSP value for this. So first we'll deal with the solubility. Solubility is mole per liter amount. So we have the mass in mg per liter. That's why we'll change it into grams by dividing it by 1000. And further, we have to divide it by the molar mass of AgCl because this is the gram per liter amount and we need the mole per liter amount to find out the solubility. So here we just find out the molar mass of AgCl. It would be the atomic mass of this Ag, that is 108 U I'm taking here, and this is 35.5, that's added to give you 143.5. So this would be divided by 143.5. So this is the solubility that you will obtain. Now, after this, we just want to find out the KSP value. This KSP for this case, because we have AgCl, equilibrium is there. So let's assume the solubility is S. It means this KSP is equal to S square. So let's place the value of S, that is 0.0175 into 10 raised to the power minus 3, and it will be divided by 143.5 and just square it. On squaring this, you will find out that this value is equal to approximately 2.5 into 10 raised to the power minus 13 mole square liter inverse square. This would be the value for KSP. And if it is so, we can easily choose option 2, in which the given value is there, as the correct option. Now let's take question number 56.